So in the case of integrating exponential functions, we're going to follow all the same rules. We're just not doing a derivative, right? And the general exponential integration rule is, again, just a chain rule. Check it out. You've got e to the u du dx dx. So you're going to rewrite this as a u substitution. So you have e to the u. Then you're going to replace du dx, which is du. You're going to integrate it that way. Then you're going to get e to the u plus c. You're going to substitute that u right back in. So it's, again, just u sub. Make sense? Now it's u sub, but it's going to look kind of crazy. Exhibit A. Notice here, we're just going to factor out that 2 and integrate e to the x dx, right? Here, we've got e to the u du dx. Here, we just have e to the x plus x. So we're going to use sum and difference rule, chain rule, and in this case, just factoring out that constant. That's all. So in the first case, 2 e to the x dx, that's equal to 2 times the integral e to the x dx, which is just equal to 2 times e to the x plus a constant. In the second case, you've got 2 times e to the 2x dx. And we're going to use u substitution to say, let's set 2x equal to u. When we do that, we get that du dx is equal to 2, and du dx times dx, excuse me, is equal to 2x, or 2 dx. So with u substitution, this is just going to become the integral of du dx times e to the u dx, but that is equal to e to the u du, which is equal to e to the u plus a constant. So substituting back in, u is equal to 2x. We get e to the 2x plus a constant. And in this final case, we've got the integral of e to the x plus x, integrated with respect to x, is equal to the integral of e to the x dx plus the integral of x dx is equal to e to the x plus 1/2 x squared plus a constant. Nothing really changes. All the same rules apply. U substitution or the general exponential rule, right? We can just pull out that constant, and there we're going to use the sum and difference rules. So constant multiple rule, U sub, and then here is just sum and difference. Constant multiple, pulling out that 2. Here, like I said, they like to call it the general exponential rule. I like to just think of it as U sub. Then the sum rule, sum and difference rule. That's it. So what about something like this? How are we going to integrate this? Well, in this case, we can again start by defining what u will be. We've got e to the 3x plus 1 dx let's set u equal to 3x plus 1, then du dx is going to be just 3, and du dx is going to be 3 dx. So this is equal to du, right? So rewriting all of this, we've got e to the u dx. Well, I can multiply by 3 and divide by 3 here, can't I? So when we do that, we're going to get e to the u times 1 over 3 times 3 dx. You check it out. That's what we just defined as du. And I can rearrange all of this now to say this is the integral of 1 over 3 e to the u du, or 1 over 3 the integral of e to the u du, or 1 over 3 times e to the u plus a constant, but u is equal to 3x plus 1. So this is 1 over 3 e to the 3x plus 1, all that plus a constant. And that is exactly what we did here. We start by saying, what is u? Then we find du dx. Then we inject a 1, right? That's how we get the 1 over 3 and the 3. We write everything in terms of du dx, then in terms of du. Integrate and substitute back in for our u. What about this? In this case, we've got the integral 5x e to the negative x squared integrated with respect to x. And I suggest that we set u equal to x squared. Let's set it equal to negative x squared. In which case, du dx is going to be equal to negative 2x. And du dx is going to be equal to negative 2x dx, which is also du, right? So using substitution now, first let's observe that 5 times x e to the negative x squared dx. Well, this can be rewritten as 5 over 2 times the integral of 2x e to the negative x squared dx. Agreed? So when we go to substitute everything back in, we have 5 over 2 times du dx times e to the u times dx. So rewriting this gives us 5 over 2 e to the u du. Right? And this just evaluates out to be 5 over 2 e to the u plus a constant. So substituting back in that u is equal to negative x squared, we get 5 over 2 e to the negative x squared plus a constant is equal to the integral of 5x e to the negative x squared integrated with respect to x. Cool. Checking your work really quick. I messed something up. What did I mess up? The negative sign, right? This needs to be negative, but if that's negative, then that has to be negative. Just to balance the signs out, right? So that becomes negative. Well, we have du dx is equal to negative 2x, so that sign's good. But over here, that needs to be negative. And that's it.
Or at the end, it's supposed to be negative equals negative 5. No, yeah. Sorry, I was like continuing on. Sorry.
So keep track of negative signs, because that's an easy one to make a mistake on. And that's one of the reasons why I like writing it this way, where we set up what u is, we set up what du dx is, then we set up what du dx times dx is, and we can follow that all the way through. Make sense? That way, if we have a mistake, we can go back and be like, what's missing here? It's a little bit quicker to actually work out. Now, something weird happens with the integration of 1 over x. The integration of 1 over x is equal to the log, the natural log of the absolute value of x plus a constant. Similarly, we can apply the chain rule to get the general log. Any thoughts on why we get the absolute value here? It's because x being negative can't be passed through here, right?
Yeah.
So if we wanted to find each of these, how might we go about it? Let's look at B, because B clumps everything together. We'd start off by saying, hey, I've got the integral of 2x over x squared integrated with respect to x. And by u substitution, I can think of u as equal to x squared, which if I do, that would mean that du dx is equal to 2x, and that du dx is equal to 2x dx. So I can rewrite all of this, right? Using substitution. And rewrite all of this as the integral of du dx divided by u integrated with respect to dx. But this is just the integral of 1 over u Integrated with respect to BU. And this is equal to the ln of the absolute value of u plus a constant. So when I substitute u back in, which we said was x squared, I get the ln of the absolute value of x squared plus c. But hey, check it out. X squared is always positive, right? So we can actually drop, in this case, the absolute value signs. Which is a convenient thing. Okay, try solving this one on your own for a second. Try solving example 5 here.
It's supposed to be the negative one.
Good catch. Good catch.
I was trying to see if you were doing something different than I was.
Nope. That was a typo. So the way to go about this problem, right, Let's start by setting what u is going to be equal to, right? We gotta start by determining u. And we say, all right, cool, we've got du dx, just because we've got u. Which means then we have what du's gotta be. And we can set this all up then using u substitution. And I should have written it with the arrow here. U is equal to 2x minus 1, and that's strictly equal, right? Because those two integrations aren't strictly equal, but they are. And we'll get into that next lecture, or even maybe tonight. If I keep moving at this clip.
This clip.
Yeah, the speed. At this derivative of lecture first time.
There we go. Thank you.
You're welcome. So once we set up that u and we find our du dx, we can replace du dx with du, right? And we can integrate with respect to u. And we'll have the integral of 1 over u integrated with respect to u. Gives us just 1/2 the ln of the absolute value of u plus a constant. Then we substitute u back in. Hey, what do you know? Bada bing, bada boom. Now, what about this case? Might be obvious pretty quick here what to do. We're going to factor out 3, right? Because that's going to give us 2x. And then here, we're going to have u is equal to x squared plus 1. So du dx is going to be just 2x. So yeah, factor out that 3 here. Pull it out front. And you're going to have du dx times dx, that's du, divided by u. You're done. Once you integrate, you're done. That's exactly what we do here. You say u is equal to x squared plus 1. Then du dx is just going to be 2x. Factor out that 3. Replace 2x with du dx. Replace x squared plus 1 with u. Hey, this is du here. This du dx times dx. So integrate 1 over u with respect to du. You get the ln of the absolute value of u times 3 plus a constant. Substitute u back in, and you get 3 times the ln of x squared plus 1 plus c. Now, why did they drop the absolute values here?
It's x squared.
Right, well, yeah, x squared is 0 or greater, right? So if you add 1 to it, it'll be 1 or greater.
Yeah.
So yeah, absolutely. It's because of the x squared plus a constant, a positive constant. Ooh, what about some of these stuff? What are we going to do in all of these? Well, here we can start off by breaking up our integration into 3 different terms, right? Here, let's not touch that just yet. Here, though, well, we can factor this top out, right? And maybe have a cancellation. So let's look at each of these.
But not B, right?
We're going to touch on B, but first we're going to do A and C. Well, if I just let y'all loose with having done only A and C and not B, then you would have gotten to B in the homework and be like, bro. Which, by the way, you will have 2 homeworks this week. I am setting them due one to Wednesday, no, both to Wednesday. They're going to be long homeworks. We're going to be upfront and honest about that now, just because it is the last chapter. We've got to get it done before I give you all your exam. I don't want to give you your exam without at least having given you some of these problems. Right?
So what else do we have to do this week? We have an exam.
Yep, you have the homework, the second homework that should be due tonight, I believe. Yep. Exam 2/3, right? Because I combine the 2 of them together. Then you're gonna have 2 homeworks. And the way those are spread out, you're gonna have 1 set of homework given later tonight. I will assign it 2 nights. But it'll be due a week from Wednesday.
So not this Wednesday.
Right, not this Wednesday.
Oh, okay, that's what I was thinking. I was
Yeah,
like,
yeah, no,
holy
not
cow.
this Wednesday, the following Wednesday.
Okay.
And then the next homework will follow a similar setup. It'll
Okay.
be assigned Wednesday night, and will also be due Wednesday. So go ahead and start on this homework ASAP.
And the exams due Wednesday, right? This exam.
Yes, this exam is Wednesday.
Okay.
Unfortunately, this is just the way the summer class breaks up. It's a really clustered class over the summer. But anyhow, getting on to these problems. The way we're going to start off that first integration, we're going to say, cool, we've got 3x squared plus 2x minus 1, all in our numerator, divided by x squared, and we're integrating with respect to x. I can break this thing up into the integral of 3x squared over x squared plus the integral of 2x over x squared minus 1 over x squared, all integrated with respect to x. Well, if that's the case, sum and difference rule, right? Right, from this point on, we're just going to apply sum and difference. We'll say, cool, this thing is equal to the integral of 3 of blah, 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 of 3 x squared over x squared integrated with respect to x plus the integral of 2x over x squared integrated with respect to x minus the integral of 1 over x squared integrated with respect to x. Now from here, we have some reductions that happen. This is going to be equal to the integral of 3 dx plus the integral of 2 over x dx minus the integral of 1 over x squared dx. And now we just solve each of these integrals individually, which we know now how to do, right? The only one that might give us a hard time is this very last one. But let's think about what this even is. This integral of 1 over x squared dx is actually equal to the integral of x to the negative second power dx. So it's a power rule, right? Not a log rule. So it's a bit of a curveball trick type question here. But notice something else. What we've got in here, we started off with this really weird rational function. We ended up with this. These two things were in no way related, right? But they are, clearly, right? The derivative of this thing is equal to this. And this thing looks ugly, weird, and nothing any of us ever want to see again in our lives. But we're going to see it a lot. So, haha. Now, in the case of C, C is actually a lot easier than what it might look like. C, we're going to start off by saying this integral of x squared plus x plus 1 divided by x minus 1 dx. Can we factor this out? Can anybody show this forward? I say we can.
Yeah.
I say that this thing can be rewritten as x squared plus x plus 1 plus x minus x divided by x minus 1 dx. All I did here was added a 0, right? Just added a 0 into that. Now we can rearrange this to be the integral of x squared plus thinking if I want to do it this way or not. Yeah, let me do it this way. Plus 2x minus 1, my mistake, plus 1 minus x divided by x minus 1. No, I don't want to do it this way. Yeah, I know. Plus 1 minus plus rather x. That's how I wanted to write this.
I was gonna say, if you go back the other way,
Yeah.
already crossed through it, so.
So what's happening here, what we're doing is just rewriting this by adding 0 and saying, hey, notice, do like that. That's my whole point of writing it this way. It's just to kind of help see what's happening insofar as you've got a cancellation for in here. Does that kind of make some sense? The other way we can go about this, and what would have been the quicker way, is to say, hey, x squared plus 1 is equal to x minus 1 times x. I'm still doing this wrong. Yeah. I am factoring this all out wrong. I am sorry, everybody. Ignore everything I just said up to this point. We're going to start this problem all over again
Right.
because I made a boo-boo. Moral of the story, we all do. We're going to add 2, subtract 2. That's what
That's
we're
what I
going to
was
do.
thinking.
Yeah,
And I was like,
that's what we're going to do. We're going to add 2, subtract 2. I was way overcomplicating it in my head. This happens sometimes. So, moral of the story again, we all make mistakes in these types of problems.
I'm sure they use difficult for us, it's fine.
Apparently. So we're going to say x squared plus x plus 1 plus 2 minus 2 divided by x minus 1 dx.
But don't you have to, you can tell me no straight up. Don't you have to, everything even on the top end, you have to do on the bottom?
No, because we're just adding 0
Oh,
in the
okay,
numerator, right?
okay, sure.
All we're doing is saying this thing is like plus 0.
Yep.
Make sense what I mean?
Okay.
We're just saying, hey, it's already there. So why not give it a name? Why not express it somehow in a convenient way in this case? So now we're going to say, cool, let's rearrange some of this. This is going to give us the integral of x squared plus x. We're going to subtract this 2 from that 1, minus 1. And then we're going to add 2 to the end, right? So just so we can see what belongs to what originally. X squared plus x divided by x minus 1 dx. Now, we're going to break this up into 2 different fractions. We'll say this is equal to x squared plus x minus 1 divided by x minus 1 dx. Plus 2 over x minus 1
You don't like that either, do you?
I don't. Because that doesn't factor those in.
I'm gonna just do x plus 1, x minus 1. You can run it on
They use long division is the way they're going to go about this problem. Okay.
that. Oh, man.
Yeah, the other way to do this is to go ahead and add x, subtract x again. Like I started to do the first time. Because we want 2x here so we can factor things out. So we're going to have to use long division is what they're saying. Okay, cool. Let's use long division.
I'm gonna stop writing down this problem. I'm just gonna pause for a bit.
That's all right.
Okay.
That is totally all right. Because some of these problems, it's not obvious right away what to do. And you just need to make 2 wrong attempts at solving this problem.
Writing down the number.
This is actually one of the reasons why I like lecturing this way is because I think everyone sees their instructor make mistakes. It makes them more comfortable to make mistakes. All right, using long division, there's nothing that we can multiply x minus 1 by to cancel out with x squared. But there is something we can multiply to cancel out with x squared plus x, right? Multiply by x to get x squared minus x, taking the difference of the two, so that's going to become 3x plus 1, right? Now, here, when we multiply by 3, cancel out this 3x. So we're going to get plus 3x minus 3. Subtracting the 2 is going to give us a remainder of 4. Remainder 4. So what this tells us, using long division, is that x squared plus x plus 1 divided by x minus 1, it is equal to x plus 3 plus 4 over x minus 1. That's what long division is telling us here, right? So we can say, cool. Let's come back up here, rewrite this. This is the integral of x plus 3 plus 4 over x minus 1, all integrated with respect to x. Excuse me. From here, we're going to break up that integrand into 3 others, right? Say you've got x dx plus the integral of 3 dx plus the integral of 4 over x minus 1 dx. And then we're just going to solve these as we normally would. So I started this problem looking at it thinking, oh, this is straightforward and easy. Cancellation, we can use a substitution. Yeah, you could actually. It's going to take a while to make it work. The better way is just to go ahead and use long division on a problem like this. Usually that's going to occur when you see that your numerator has a higher power than your denominator. It's a good sign to use either factoring or long division. Yeah. So, as you just saw, it is easy to over and underestimate some problems. And it's easy to overthink these things too. So don't beat yourself up if you yourself overthink a problem or don't immediately see how to solve it. Now, For b, in the case of the integral 1 over 1 plus e to the negative x, what are we going to do here? What do you all think?
My initial thought is to fix the negative x, but I don't know.
Yeah, we
Any
want to do
sense.
something with that, right?
Yeah,
So the method they use is going to be to multiply by 1.
okay, yeah,
And what's happening here is you get the integral of e to the x over e to the x times 1 over 1 plus e to the negative x dx. So obviously right away, you're just going to have e to the x and the numerator coming up, right? E to the x times 1, it's going to be e to the x. And then e to the x times e to the negative x, that cancels to give you 1. Now, compare these two. How do they relate to each other? This is where the next trick comes in. Now we're going to say, if I were to take the derivative of e to the x plus 1, I would just get e to the x. Why don't we set this equal to u? U is equal to e to the x plus 1 du dx is equal to e to the x, and du is equal to e to the x dx. So when we use u substitution, u is equal to e to the x plus 1, right? When we use this substitution, we're going to get is the integral of du over u. Well, this is equal to the ln of the absolute value of u plus c. So substituting u back in now, u is equal to e to the x plus 1. We get the ln of the absolute value of e to the x plus 1 plus a constant. That is exactly what they ended up doing. So B takes a trick. It takes first multiplying by 1, and then it takes representing e to the x plus 1 as u. Now looking at this final problem, there's still a problem in my math, and I don't see where it is. It's because I was supposed to come out to be 2, not 3. So I made a boo-boo in even the long division. So in that last problem, C, doing the long division, you're going to get this happening. And this is where I made my mistake. In the long division, we've got x minus 1 divided into x squared plus x plus 1. When we multiply x minus 1 by x, we're going to get x squared minus x. When we subtract the two values from each other, when we subtract x squared plus x, and pull from it x squared minus x, we get 2x down here plus 1. That was where my mistake was. So now we're going to multiply by 2 plus 2. We're going to get 2x minus 1 or -8 -2. The two x's are going to cancel, so you're gonna get +3. You're gonna have a remainder of 3. So turn back over to here. We should have x + 2 with a remainder of 3 over x - 1, which is exactly what they have.
Figured it out.
Yes. Typos all over that problem. That was my bad. So problems like this, it is really easy to make mistakes. Very easy. You just need to make 3 mistakes, and I'm paid to do this stuff, right? To that end, if you make a mistake, shake it off. It's really easy to let it embarrass you, but just shake it off and take a break for a little bit, come back to it in a few minutes. Having said that, it is 9 o'clock, so y'all are free to go. If you don't have any questions, I'll stick around.